and I've learned a lot from this course and this project, from the basics in design of sensors to actually prototyping a device. This whole experience from generating idea and design to purchasing and put everything together and finally testing and debugging the device, they're all very valuable to me.
Hi, my name is Mahfuzuddin Kazi, and I really enjoyed this course, especially being able to apply everything I've learned in the last 2-3 years in a project. So like we learned about op-amps in the past, but being able to actually use it in a project was really nice, and seeing how like everything we've done wasn't a waste of time. And I really liked learning about the different sensors, the ultrasonics, the gyroscopes, the accelerometers. I've used them in the past, but being able to actually see the details and how they work and the internal mechanisms was a really nice touch to the course. And the labs obviously helped with everything else too. Yeah, thank you.
Hello, my name is Zakaria Ahmed.
So, what is the HCI-Glove? It is designed with the purpose of improving human-computer action. So, in our case, instead of using a keyboard or a mouse to control a computer, you can use more natural movements from your hand or from your body to help interact with a device. So applications can include exoskeletons, precision surgery, presentations, virtual reality, and machine learning. Features. So in essence, our device is basically a glove that can interact with a computer based on different hand gestures. So you can control the volume, you can swipe left or right, or you can have a variety of different hand gestures, like maybe zooming in, zooming out, like how you do on phone. But instead, you would have a glove that can translate that information to a computer or to a device. And then we just wanted to improve the way how we interact with the devices around us instead of just the traditional sense where we use a mouse and keyboard.
So our glove is basically consists of one glove, 2 accelerometers, 4 flex sensors, and 1 national instrument data acquisition unit. I'll start with flex sensors first. They are basically variable resistors whose resistance is going to increase as we bend them. The maximum resistance is achieved when it's approximately 90 degrees. We use them to differentiate different hand gestures. And those hand gestures are going to determine what kind of feature we want to, what kind of function we want it to perform. And accelerometers are used to detect motions when we already have a certain hand gesture, and they are the computer is going to react according to those motions. And the data acquisition unit basically converts the analog signal into digital ones and give it to the computer for processing. And finally, we would have lab view to control what kind of behavior the computer is going to perform according to the data we acquired. Okay, this circuit diagram actually shows the connections between all of the components. Still, I'm going to start with the flex sensors first. So this circuit right here, they are what these orange little boxes represent. So to start with, we have a 3.3 volts VCC coming in from here, and we will have a flex sensor as the variable resistor. Together with another resistor in the bottom, they form a voltage divider, and as the resistance of the flex sensor changes, the voltage at this point would also change, so that we can generate a voltage signal for the data acquisition unit to process. And this is basically just a buffer to increase the input impedance. And finally, the signal will be routed to this data acquisition unit. Let me actually erase these. Okay, so these are the actual pin assignments for our flex sensors. So pin number 6 belongs to the thumb, pin number 7 belongs to the index finger, pin number 8 belongs to the middle finger, and pin number 9 belongs to the ring finger. And these two accelerometers, they generate voltage, analog voltage signals, so we don't need any additional circuit before sending it to the data acquisition unit. And these are their actual pin assignments. This accelerometer belongs to the thumb, and this accelerometer actually belongs to the index finger. And yeah, that's it.
Okay, so here is our LabVIEW block diagram for the HCI-Glove, and it's split into 5 distinct areas. We have the actual data acquisition, so we have the DAC assistant, and then it takes the signal and splits it into its individual components for each sensor. And then on the bottom over here is where we actually get the, we do the gesture recognition. So we take the input from the flex sensors and we find out which ones are bent. So for the flex sensor, we have like a gesture that looks sort of like turning a knob. So we check if that is true, and once that is true, we get this indication that turns the volume on. And then we get the angle from the accelerometer on the thumb. So, and then we add that to the current volume. So at the top we have it at 0 degrees, and then as we turn, we go towards 90, and then that's what we add on to the volume. So at the beginning, our volume is 0, and we're using shift registers. It goes into the input, and then our new input then becomes the angle that we use to turn, and then it goes back into the output shift register, and then it does the entire loop. For the swiping, it's a little bit more difficult, where in this case we have our gesture as this is our gesture, which basically has the ring fingers bent while the other 3 are straight. The issue we were having with this case was because we had to differentiate between a left swipe and a right swipe. So we found that the signal was different depending on which direction you were going. So if you're going to the right, the signal would look sort of like this, the acceleration signal. But if you're going to the left, it would first go down versus up. So we would have to differentiate these two signals depending on which direction I'm going. So the way we did that was we found out if I have a positive slope before a negative slope. So we found the time index where these 2 points occur. If the positive was before the negative, we are swiping right, and if the negative was before the positive, we're swiping left. So that's how we did that. So that's this part over here, and then we would again output to the screen if it's a left or right swipe, and then we do the actual we actually send that input to the computer. And then thirdly, we have this extra case at the top over here, which basically could be anything. Right now we have it as a space. So the gesture right now is a thumbs up. So when the thumbs up is seen, it sends a space input it simulates a space input like a keyboard and sends that to the computer. And at the bottom, what we have is we simulate a signal to output a sound. This is used when we're testing the sound volume for the sound. So it just generates a few beeps that we can hear. But otherwise, yeah, that is our code for HCI-Glove.
Hi, so now we're going to show you a demonstration of the HCI-Glove. So if you come over here, what we have is a normal glove, and then we have 4 flex sensors, and this is what the flex sensors look like. And then we have 2 accelerometers, one on the index and one on the thumb. So the flex sensors go to the breadboard where they're connected to a op amp, and then they go into the DAC, whereas the accelerometers go directly straight into the DAC. So the first thing we're going to show you is the volume control. So we have this nice VI laid out for you. So this is a meter showing us the volume from 0 to 100. and then we have a few indicators showing which gesture I'm currently in. So if I go into my gesture control mode, I have my gesture as, you can see the indicator turns on, showing that I'm in the gesture mode. And then I will rotate my arm clockwise, it increases. When I go back, it decreases. Increase, and then decrease. So pretty cool over there. So next we have the swiping feature, which has these two, and as you can see the sliding turns on. So, and then we have a nice waveform chart over here, so when I swipe left, the indicator turns on, and then we see the waveform chart, and when I go right, I have another waveform chart. Same thing. So we can show you in a PowerPoint how this can be used. So I swipe to the right, and then and back.
So in general, our project is a success. We managed to get the computer to differentiate different gestures we have. Also, we made the volume control functionality work flawlessly, but the swiping functionality does have false readings occasionally. It can't always correctly differentiate whether we are swiping left or right. So in terms of future improvement, first we can improve the swiping functionality by having some additional hardware dedicated to detecting and differentiating the input pulses we have. Also, we can always add more gestures and features to our glove to suit for a wider industrial need. And finally, we can make the glove a bit easier and more comfortable to wear, since it's important, a very important customer experience. And yeah, thank you for watching.